Characteristic compressive strength. Concrete designation. 28-day standard cube compressive strength is designated as the strength of concrete. As per ISO 562,000, the concrete is classified based on strength with grade designation as per table 2, page number 16. So you can open page number 16 of ISO 562,000 and look into table number 2. There you will find the classification of concrete as ordinary concrete, standard concrete, and high strength concrete. There you will find a column in which the grade designation has been given. Like if I take an example of M25 grade concrete, M represents mix, 25 represents the characteristic compressive strength of 150 mm cube at 28 days in Newton per millimeter square. Now, when you are going to say a concrete is ordinary, if the strength is less than equal to 20 Newton per millimeter square. For standard concrete, the strength is going to lie in between 25 Newton per mm square to 55 Newton per mm. Whereas for high strength concrete, it will be in the range of 60 Newton per mm square to 80 Newton per mm square. Cube strength and characteristic strength. The difference between cube strength and characteristic strength of concrete should be clearly understood. Cube strength refers to the strength of one cube, whereas characteristic strength refers to the guaranteed strength of the whole concrete mass. Now, you go to page number 67 of ISO 562,000 and look into clause number 36.1. You are going to find the definition of characteristic strength. Let me read the definition. It says, characteristic strength means the value of the strength of the material below which not more than 5% of the test results are expected to fall. That is, the probability of test result being lower than specified characteristic strength is 5 in 100. It means that 5 number of samples out of 100 samples will have strength less than the characteristic strength. For example, a concrete will be designated M25 if there are 5 samples whose strength is less than 25 Newton per mm square when the test is being conducted on 100 samples. To analyze the test results of material strength like cube strength of concrete or tensile strength of reinforcement, etc., the statistical methods are used. Let us take an example to understand the statistical method to decide the characteristic strength of concrete. Consider that we have collected a set of n results or observations such as x1, x2, x3, so on till xn, which shows a scatter. Separate the data into groups by selecting the length of the interval of the variable. Now find the number of values of the variable which will fall in that group, that is frequency. Now plot the histogram and density function. Observation. The density function obtained from an experiment results is awkward to handle in subsequent manipulation. That is, you cannot interpret or do any kind of mathematical operation on the density function obtained. Now, what can be the solution? This difficulty can be overcome by using the ready-made distribution curves available in standard statistical tables. For concrete cube test results, the assumption of normal distribution or Gaussian distribution is sufficiently close to reality. To get an insight, consider the data which represents the strength of concrete cubes prepared and tested in the same condition. The total number of samples are 30 in number. From the data, it can be observed that the minimum value is 22.5 Newton per mm square and maximum value is 30.5 Newton per mm square. Now, let us take a group interval at 1 Newton per mm square and tabulate the frequency distribution. The group considered is starting from 22 till 31. So the group is 22 to 23, 23 to 24, 24 to 25 and so on till 30 and 31. Now you can count how many test results are in the group of 22 to 23, 23 to 24, 24 to 25 and so on. For the given data, plot the histogram and join the midpoints of each of these bars to get the density function. Now you can clearly see that this density function obtained from an experiment result is awkward. As stated earlier, the density function obtained from an experimental result is awkward to handle in subsequent manipulation. Not exactly, but close enough. This can be represented by normal distribution curve, thus allowing us to interpret the experimental data. Hence, let us now see the important features of normal distribution curve. Before applying a normal distribution curve, let us discuss about mean and standard deviation. Mean is a measure of central tendency or tendency of getting grouped about a central value and is defined by the formula x bar equal to summation of individual value of sample divided by total number of observed values. Next is standard deviation. It is a measure of dispersion or scatter of the value about the mean. The formula is calculated by the expression s equal to square root of summation of difference between individual value of sample minus the mean value of sample whole square divided by n minus 1. N is total number of observed values. Equation of normal distribution curve. This expression gives an equation of normal distribution curve. We can see from this graph that this curve extends from plus infinity to minus infinity. The curve is bell-shaped, as can be seen. It is symmetrical bilaterally. Both sides, mean, mode, and median coincide. It has two inflections at the points where the curve changes from convexity to concavity. Properties of the normal distribution curve. As can be seen from figure that the area under the curve between the abscissa x bar minus s to x bar plus s is 68.2% of the total area under the curve. That is, the probability of the cube strength of any sample lying between x bar plus minus s is 0.68. Similarly, other probabilities are shown. Now, let us see how to find characteristic strength of the concrete from the set of cube compressive strength data. The data which you are going to have is to be plotted in form of normal distribution curve. Now, it can be shown that 95% of area under the graph lies between minus 1.65 s and plus infinity. This means that there is only 5% probability that a result will fall below mean strength minus 1.65 s. This is applicable only for material strength. Since 5% probability of strength falling below certain strength is characteristic strength, so characteristic strength equals to mean strength minus 1.65 times standard deviation. Standard deviation result. Smaller value of standard deviation will result in a curve with a dominant peak, whereas a larger value will result in a flatter curve, depending upon the level of control exercised in the manufacture of concrete. As can be seen from the graph that for a good quality control, the standard deviation is going to be less, whereas for a poor quality control, the standard deviation is going to be more. Can you compute the characteristic strength of concrete from the cube strength results on 30 samples?